Hello students, we are at the most important part of the chapter indefinite integration. The module here states integration by parts, that is integral of u into v. Very important derivation in this particular module. Now integration by parts, the theorem is as follows. It says if u is a differentiable function of x and v is an integrable function, then prove that integral of uv dx is equal to u integral v dx minus d by dx of u into integral v dx the whole dx. A very important derivation, my dear students. We have only two informations with us in this statement. It says u is a differentiable function of x and it says v is an integrable function of x. So if v is an integrable function of x, integral v dx will exist and will have a finite value, and that value I'll assume it to be w. If I apply definition of integration, then we can say that dw by dx should be equal to v. This is by the definition of integration. Let us write them as equation 1 and 2 respectively. We require this information. Now we know that d by dx of u into w, if I have two functions which are multiplied and I wish to take derivative, it can be written as u into derivative of w plus w into derivative of u. Is that okay? Let us go further. D by dx of u into w will be written as u into dw by dx. Now dw by dx, my students, just some time back we saw has the value as v. So we have u into v plus w into du by dx. And how did this happen? We have written the justification. It's from equation 2. Now my dear students, what I have currently as my last step is of the form d by dx of g of x, where g of x is u into w, which can be said to be equal to sum f of x, where f of x is the entire right hand side. Now this is in the form of definition of integration. D by dx of g of x is equal to f of x. Then we have integral of f of x. Integral of f of x dx is equal to what? It is equal to g of x. So integral of f of x means integral of u into v plus w into du by dx is equal to g of x. That means is equal to u into w. Is that okay, my dear students? And this is coming from definition of integration. Now let us see how do we proceed. Now my dear students, if you remember the proof that it requires only one integral on the left hand side, and that integral is integral uv dx. So let us write this as two separate integrals. So integral uv dx plus integral w into du by dx the whole dx is equal to uw. As I said earlier, we require only one integral on the left hand side. So let us keep this integral on the left hand side. Let us transfer this integral to the right hand side here. So we get uw minus of integral w into du by dx the whole dx. Is that okay, my dear students? Now let me put this step up here for our reference. We require to make some value substitutions. I require the value of w. So let us see what is the value of w. Now integral uv dx, I keep it as it is. Value of w is nothing but integral of v dx. So we have u integral v dx minus of du by dx integral v dx the whole dx. That is what is our proof, that this is what they had asked us to derive. So we have integral uv dx is equal to u integral v dx minus integral du by dx integral v dx the whole dx. Now let us see what is to be done with this rule. We have to decide about the two functions, which one will be u, which one will be v. So here we can choose the functions, the first function as the function which comes first in the serial order of letters liate, L-I-A-T-E, where the letter L stands for a logarithmic function. An example of logarithmic function can be something like log x or log of 2x or log of x square plus a square, any log term. I stands for inverse trigonometric function such as tan inverse x, cos inverse root x. A stands for algebraic function. Now algebraic function like x cube or root of x square plus a square, anything which involves x. Trigonometric function, T stands for trigonometric function like tan x, sin 2x, and now the last one, E stands for exponential function like e raised to x and a raised to x. So these are the 5 functions we'll have. The first to appear in this will be taken as u. Now we need to remember some points here, a very important note. Now whenever we are integrating and we have product of 2 functions, the function which can be integrated easily should be taken as the second function. So here it is important that we make a proper choice of the function u and v. Also, my dear students, if there are 2 functions such as one is logarithmic, second is inverse trigonometric, then they have to be taken as the first function. And in such integrals, if there is only one function given to us, the second function will be taken as 1. These 2 are important points, and we will see these 2 points as and when required with the sums again and again. That's all we have in this module. Thank you very much.